Hello friends, today we discuss the gear manufacturing. Okay, now what is meant by the gear manufacturing? What are the introduction for about the gears? Gears are basically wheels having on its periphery equi- equispaced teeth which are so designed to use in various mechanisms and devices to transmit the powers and motions positively, so called as the without any sleeps between the parallel intersecting and non-parallel non-intersecting shafts. These are the primary functions for the gears. So what are the materials required for the gears? There are the two types of the materials. First is the metal and non-metals. Metal like cast iron, cast steels, bronze, aluminiums, etc. And also the non-metals used for noiseless operations like the plastics. What are the methods for the gear manufacturing? Okay, we discussed the castings, metal forming and metal removal are the method for the gear manufacturing. Next we discuss the castings. Okay, casting metal and metal formings. Okay, gear manufacturing. This figure shows the forming and machining are the two groups for the gear manufacturing processes. In that forming, the casting, sintering, injection molding, extruding, cold drawing, stamping, preforming, and forging are comes under the group of the forming gear manufacturing processes. Now, let's go to the machining processes. In that machining process, we remove the material from the plants. Okay, the process is called as roughing, form milling, rack generations, gear shaping, hobbing are major machining processes to generate the gear. Okay, there are some finishing operations required for the machining processes. Okay, the finishing process considers shaving processes, grinding, burnishing, lapping, and honing. They are comes under the machining groups. Okay, now let us discuss the casting processes. Okay, all of you know the casting processes. There are different types of casting, but in that different casting processes, we use only the sand casting, die castings, and the investment casting are most suited for to manufacture the gear because they are applicable for wide variety of the materials. Toothpaste is built into mold at low cost. Need minor finishing operations to improve the accuracy of gears. Next method is called as injection molding. Gear is generated or manufacturing by injection molding. Injection molding is used to make non-metallic gears in various thermoplastics such as nylon acetates. These are low precision gears in small size. Okay, they are generally produced in a small size gear by using the injection molding process, but have the advantages of low cost and ability to run without the lubricants at light loads. Okay, what are the applications of the gear producing by the injection moldings? Injection molding gears are used in cameras, projectors, printers, windshield wipers, speedometers, lawn sprinklers, washing machine, etc. What are the materials for injection moldings to generate the gears? There are the different types of materials like nylon, cellulose acetate, polystyrene, polyamide, and phenolics. Now come to the next. Okay, extruding is the best process for to generate the gears. The extrude is used to form teeth on long rods. Then it is the extruding processes we can produce a long rod of the teeth, which are then cut into usable length and machined for bores and keyways, etc. Non-ferrous metals like aluminum and copper alloys are commonly extruded rather than the steels. This results in good surface finishes with the clean edge and pore-free dense structure with a higher strength. The figure shows the shape of the gear generated by using the extruding processes. Okay, what are the materials required for the extruding processes? Is aluminum, copper, naval brass, bronze, and phosphor bronze are the materials that are commonly used extruded. What are the applications of the gears generated by using the extruding processes? Generally, the spline hollow and the solid shafts are produced by the extruding processes. Sector gears, okay, one of the important application to generate the extruding process is the sector. These sector gears are generated extruded and the various gears are shown in figures. Okay. Now come to the next process is the metal roll. This is the biggest and most popular process to generate the gears. Okay, there are a different way we can generate the gear by using the material removal. Okay, in that first is called as a machining. Produced by the machining process from cast, forged and the hot roll blanks. These are the pre-requirement for the machining process. We use the blanks in the form of the casted blanks, forged blank and the hot roll blanks. Okay, there are the different types of the cutters are used for generating the gears. Okay, here the figure shows the different types of cutters. Okay, first is called as the disc types of cutter. These are the disc types of cutters. And second is called the rack types of cutter. These are the rack types of cutters. Shape cutters. These are the different shape types of cutter for shaping processes. And fourth is called as the hop cutter. Most of the gear generated by using these hop cutters. These hop cutters having the high productivity applications. Okay, these are the different cutters are used to generate the gears. Okay. Now gear cutting with a single point form tools. Okay, gear cut on shaper planers by using the dividing head. The teeth are cut and gear blank is indexed like milling machines, but cutter is single point tools and its motion is reciprocating. The figure shows the single point form tool cutter. These are the tools which are reciprocate over these gear planks, and gear plank is indexed one by one teeth. Okay. Method is very slow and not universal. We show the video for the gear. Here is the shaping tools or single point cutting tools which can generate the gears. Their gear blank is shortly indexed to generate a one gears. These are animated animations for the generation of the gears. Okay. Next is called as the broachings. Now, broaching is one of the best process to generate the gear in a single strokes. It produces a highly accurate gear with an excellent surface finish on by using the broaching machines. Generally, it produces the internal gear sectors or racks. Okay, these are the broaching tools. We can generate these gears. Now, next is called as the form milling. Okay. Most of the gears generated by using some milling operations. Okay. Form milling. The disc cutter shapes conform to the gear to space. Each gear needs a separate cutters. Each gear needs a separate. These form cutters are used to generate a form milling. These types of cutters. And second is by using the end milling cutters. The end mill cutters space conform to tooth spacing. Each tooth is cut at a time and then index for the next tooth space for the cuttings. These are the form cutting. We can produce a form cutters to generate a gear form. Okay. Production of the gear teeth by machining on generation principles. Okay. Here is called as gear generation principles. Generation method is characterized by automatic indexing and ability to single cutters to cover the entire range of number of teeth for given combinations of modules and pressure angles, and hence provide a high productivity and economy. Okay. Here we discuss the external gear teeth generation by rack type cutter. We use the rack types of cutters for generation of the gears. Okay, here we discuss the Sunderland's method using these rack type cutters. Principle of this generation process where the rack type HSS cutters. Okay. The cutter is an HSS materials having the rack and the clearance angles. Okay. The rack and clearance angles on the rack cutters. The rack is reciprocate again the gear blank, and gear blank is continuously rotating with the racks. Reciprocate to the accomplished by machining actions, while rolling types interactions with the gear blanks like a pair of the rack and pinions. Okay, we take a video for this Okay, this is the animations for the rack types cutting action. Okay. These are the gear blanks. These are the rack types cutter. They are continuously reciprocated again these gear blanks. They can generate the gears on a gear blank continuously. Okay. Now the favorable and essential application of these methods and machines include the moderate size, strength, and helical toothed external spur gears with a high accuracy, and finish cutting the teeth of double helical gears with a central recess, cutting teeth of the straight or helical fluted cluster gears. However, this method needs though automatic or few indexing operations. Okay. Now, next is called as the gear shapers. Okay, this gear shaper is again the part for the generation based on the generation principles. In generation principle, the gear shaping is similar to the rack types cutting processes, excepting that the linear type rack cutters is replaced by the circular cutters. Here is called as circular cutters replaced by the rack types cutter. Actually, both operations are same Sunderland process and gear shaper process, but here we use only these circular cutters are used. The circular cutter reciprocate against these gear blanks. At that time, the circular cutters also rotated. Okay, linear type rack cutters replaced by the circular cutters. Okay, where the both cutters and the blanks rotate as a pair of these spur gears in addition to the reciprocation of the gear. Okay, we'll take a short video for the rack type. Okay, here is the circular cutters reciprocate against these blanks, and now these blanks continuously rotated as well as the cutter also rotated. Now, okay, to start the cutting a gear, the tool is fed into the gear blanks before each cutting stroke. When a required depth is reached, inward feed stops and the cutter and the blanks slowly start rotating. The gear is cut in one complete rotation of blanks. The cutter reciprocates at about the 100 strokes per minute, where we use the 100 strokes per minute for the cutter. Then both the straight and helical two gears can be cut on the gear shaper. Okay, these are the gear shaper operations. What are the advantages of the gear shapers? One cutter used for cutting all spur gears of same modules. Okay, we use the same modules gears. Is suitable for cutting cluster gears. The method is versatile and cut spur, helical, internal gears, rack, spline, etc. Okay, then what are the next advantages? Is separate indexing is not required at all. There is no separate indexing is required for this process. The productivity is also higher. Most of the gear or internal gear producing by using this shaper processes, gear shaping processes. What are the limitations? The process having limitation, the cutting action is reciprocating and cutting takes place only during one half of the strokes, so only half of the machine's time is spent in metal removals, and separate helical guide required for cutting helical gears. Now, next process called as the gear hobbing process. Is the most famous and most used process in the industry is the gear hobbing processes. In that, hobbing is the process of the generating the gear teeth by means of the rotating cutters, also called as this cutter is called as a hob. Okay, first we show the hob cutter. There is a hob cutters against the blanks. Okay, looks we have like a single or multiple start worms. This cutter having single or multiple starts worms or screw types cutting. The gear hobbing is a continuous cutting operation. It rotates about an axis normal to that of the gear blanks, cutting into the rotating blanks to generate the teeth as shown in figures. Here we can producing gears. Okay, we take a short video for that. gear by using the gear hobbing process. There is a gear hover. There is a gear hover. This is a gear blanks. Both are rotated. They can generate the gear. Okay. Now, what is mean the hop cutter? Here show the hop cutter. Generally, this is the worm type cutters having single or multiple start. Each teeth having its rags and clearance angles. Okay. The hop and blank are connected by means of change gear. The ratio of hop and blank speeds such that during one revolution of the hop, the blank turns through as many teeth as there start on the hop. To start cutting, the hop is made to clear the blanks. It is then moved inward to obtain required tooth depth. Then hop is fed in a direction parallel with the axis of rotations of the gear called as generally the axial hobbing. There are two methods for the axial hobbing and okay, here we show the gear hobbing processes. Here is the gear hobbers. Here is the gear blanks. The gear blank rotated. They also rotated. Okay, the hob is rotated at a suitable RPM and simultaneously fed to the gear blanks. Gear blank is fed, hover is fixed and is a rotating one. The gear blank is also kept as a revolving. RPM of both gear blank and gear hob are so synchronized that of each revolutions of gear hob, the gear blank rotates by a distance equal to one pitch distance of the gear to be cut. Motions of both gear blank and hob are maintained continuously and steady. These are the gear hobbing processes. Now, there are the different types of gear hobbing processes depending on the direction of the feed of the gear hob. First is called as axial hobbing, radial hobbing, and tangential hobbings. Okay, axial hobbing used to cut the spur gears and helical gears. We see in your figure video the axial hobbing process. Then go for the radial hobbing. Feed of the hob is radial towards the center of the blank, used to produce the worm wheels. Worm wheels can be produced by the radial hobbing processes. Tangential hobbing used to generate the worm wheels. They are the worm and worm wheel gears produced only by using the hobbing processes. What are the advantages of the gear hobbing processes? The method is versatile, generates spur gear, helical gear, worm gear, and worm gear. All types of gears are produced by using the gear hobbing processes. It is rapid, economical, and highly profitable. It is suitable for medium, large, and batch productions. The cutter is universal cutters, easily available in the markets. Okay. What are the disadvantages? Cannot generate the internal gears by using the gear hobbing process. These are the major disadvantages of these processes. Okay. Now come to the gear finishing processes. There are different types of gear finishing processes. For gear finishing processes, for smooth running, good performance, and the long service life, the gear needs to accurate in dimensions and forms to have high surface finish and to be hard and wear resistive at their tooth length. The gear is after performing and machining. The finishing generally by first is called for soft and unhardened gear shaving or gear rolling or polishing process. For hard and hardened gear, okay, for this we use the grinding and lapping processes. For soft but precision gear, shaving followed by the surface hardening and lapping processes. Okay. Now we start with the gear shaving processes. Okay. What are the gear shaving processes? Gear shaving is a finishing operation that removes small amount of metal from flank of the gear teeth. You can remove the small amount of material from the flank of the gear teeth. We can shave the flank only. We can remove the small amount of material and it get finished. Gear shaving may correct small errors in tooth spacings, helix angles, tooth profiles, and concentricity. Shaving improves the finish on tooth surface and can eliminate tooth end load concentrations, reduce gear noise, and increase the load carrying capacity. Okay, these are the gear shaving application. In rotary shaving, cutter and the gear are run in mesh. In rotary shaving, the cutter has same basic form as the rough cut gears. The teeth of the cutters have groove cut across the flanks in planes at right angles to the axis of the cutters. Why axes are crossed is to create an actions of reciprocal sliding between the cutter teeth flanks and gear tooths. So shaving improves the finish on tooth surface and can eliminate tooth end load concentration, reduce gear noise and increase load carrying capacity. Here is the gear shaving cutters. The flank of the teeth cut by the groove. These are used to remove the small amount of material from the gear teeth. This is gear shaving cutters. What are the advantages of the gear? There are various advantages of the gear shaving processes. Okay, easily performing short cycle times and high productivity, high versatile machines, reasonable setup times, easiness of input profiles and lead testing compensations, possibility to finish gear close to shoulders, low tool cost per piece, low investment for purchase of the shaving machines. Okay, what are the disadvantages? Necessity to shave before heat treatment is a primary requirement for the gear shaving process. Distortions and thereafter errors due to the following heat treatment. The shaving result is highly conditioned from the pre-machine conditions of the workpiece. Occasional impossibility to use the shave tools onto gear with a small number of teeth. These are the gear shaving. Now we show the gear grinding processes. Okay, here is called a grinding processes. In grinding process, the figure shows the grinder wheels having the gear profiles. Okay, and then you can grind the gear tools to remove it. Okay, there the grinding is also done by on two principles: the forming principle, and the gear generation principle, which is more productive and the accurate. Okay, other gear finishing operations are gear lapping and gear honing processes.